Welcome you all. I am Dr. M. Tamilselvi, Assistant Professor, Department of Chemistry, Sita Lakshmi Ramaswamy College. In this video, we are going to discuss the topic acids and bases. Our ancestors have been using tamarind and lemon juice to add shine to copper vessels. Our mothers never stored pickles in metal containers. How did they know that tamarind or lemon juice will work? It was only a few hundred years ago that it was known acids taste sour and substances like tamarind and lemon juice contain acids. It was all common collective wisdom which was passed from generations to generations. In this video, we are going to see the definition of the terms acids, bases, pH, and buffer. We are going to see some examples of common household acids and bases. We are then going to discuss the properties of acids and bases. We will also differentiate between strong acids and weak acids. Also, we will see the differences between strong bases and weak bases. Towards the end of the presentation, we will recognize the importance of pH and buffer in everyday life. In the 19th century, the scientist Robert Boyle, he labeled substances as acids and bases. He was successful in characterizing acids and bases. However, he could not explain the behavior based on their chemical nature. It was later in the 19th century that the scientist Arrhenius he put forward his theory of acids and bases. As per Arrhenius' definition, an acid contains a hydrogen atom and dissolves in water to form H+ ions, whereas a base contains hydroxide and dissolves in water to form OH- ions. As you see here, HCl, hydrochloric acid, dissolves in water to form H+ and HCl- ion, whereas NaOH, which is sodium hydroxide, dissolves in water to form Na+ plus OH- ions. So, as you see in the slide right here, there are few of the common examples of acids which we come across in our everyday life. Acetic acid is found in vinegar. Citric acid is found in lemon, oranges, and other citrus fruits. Carbonic acid is found in cola. Tannic acid is found in the tea. So, acids are not evil substances. They are part and parcel of our everyday life. Acids taste sour, they are corrosive to metals, and they become less acidic on addition of. Here we see some examples of common bases which we come across in our day-to-day life. Antacid tablets, they contain calcium carbonate, magnesium hydroxide, etc. They are bases. The glass cleaners, which are used to add sparkle to the glass, again contain bases in them. The drain cleaners are also bases. Baking soda, which is used in our kitchen, and bleaching powder, which we come across in our home, are all bases. Bases taste bitter. They are going to be slippery to touch, and they become less basic when acids are added to them. Acids are going to be classified as strong acids or weak acids. So when a covalent acid dissolves in water, the proton transfer forms H3O+ ion, and this process is called as dissociation. When a strong acid is going to dissolve in water, 100% of the acid dissociates into ions. As you see here, HCl, when it is dissolved in water, it forms H3O plus Cl minus, and we have a single-headed arrow here. And common strong acids are hydroiodic acid, hydrobromic acid, hydrochloric acid, sulfuric acid, and nitric acid. Talking about weak acids, we already have seen vinegar, which contains acetic acid. Weak acids, they are going to dissolve in water, and only a small fraction of the acid is going to dissociate into ions. So that's the reason why we have a double-headed arrow here, which means that the reaction never goes to completion. Common weak acids are phosphoric acid, hydrofluoric acid, carbonic acid, and hydrocyanic acid. Talking about bases, strong bases dissolve in water to form 100% of dissociation. For example, sodium hydroxide in water, it has a single-headed arrow here. That means 100% of the ions are going to exist as Na plus and OH minus. Whereas a weak base dissolves in water and it forms only a fraction of the OH minus ions. And that's the reason why we have a double-headed arrow here. So ammonia is an example of a weak base, and it dissolves in water to form ammonium ion, which is NH4 plus and OH minus, as we see in the equation. When we look into this term, which is called as pH, which it means power of hydrogen, it shows the tendency. pH can also be defined as the potential of a substance to attract hydrogen ions. So as we see here, the mathematical expression is pH is equal to negative logarithm of hydrogen ion concentration. The lower the pH, the higher is the concentration of the H plus ions. So because of the negative sign in this equation, when the hydrogen ion concentration increases, the pH decreases, and vice versa. So for acidic solutions, the pH is going to be less than 7. For neutral solutions, the pH is going to be equal to 7. And for basic solutions, pH is going to be greater than 7. The pH scale is used to denote the concentration of hydrogen ions. So as we see here, the pH equal to 7 represents pure water. Whereas when we go down the scale, we have milk and some citrus fruits like your strawberries and tomatoes, which fall between somewhere 3 to 4. And your lemon juice falls at a pH of about 2. And at pH equal to 1 comes your stomach acid, which is hydrochloric acid. And close to pH 0, represented by the battery acids, which are very harmful to human tissues. And talking about the other side of the scale, around pH 8, we have antacid tablets. And around pH 10, we have glass cleaners and other household cleaners. And when the pH goes closer to 14, it just becomes very dangerous to human tissues, and your drain cleaners, which is 4% NaOH, falls on that range. Our stomach produces hydrochloric acid, which helps in the digestion of our food. When we eat a lot of acidic food or spicy food, our stomach secretes more amount of hydrochloric acid. As a result, this causes irritation and sometimes pain too. So this is prevented by eating antacid tablets. The antacid tablets react with the excess acid and it undergoes a neutralization reaction. A neutralization reaction is nothing but an acid-base reaction that produces salt and water. So when we have an acid which is represented as Ha and it reacts with a base which is MOH, it forms H2O, which is water plus salt. The acid Ha, it donates a proton H plus to the base OH minus and it thus forms H2O. The anion A minus from the acid combines with M plus from the base to form the salt Ma as shown in this equation. Talking about buffers, a buffer is a solution whose pH changes very little when acid or base is added. Most buffers are solutions composed of roughly equal amounts of a weak acid and the salt of its conjugate base. Example for a buffer of this case is acetic acid and sodium acetate buffer. The buffer resists change in pH because the added base is going to react with your acid. And if you add acid, that is going to react with the conjugate base. Having known the definition of pH and buffer, it's time for us to understand the prime importance of pH and buffer in our human system and for our environment. The blood pH, it remains constant around 7.4. If a person is diabetic, this pH falls to 6.8. The constant pH in the blood is maintained with the help of carbonic acid bicarbonate buffer in the blood. And if we look into the gastric juice, the pH is around 1.6 to 1.8. And if we are going to eat some spicy food, this is again going to change. And it would cause vomiting and ulceration. Most of the biochemical reactions which are taking place in our body falls in the narrow pH of about 7.4 to 7.8. If there is any disturbance in this pH range, then the whole process is going to stop. When a person exercises, the muscles produces a lot of protons and these protons get dumped into the blood. As a result, this will tend to raise the pH of the blood. However, because of the carbonic acid bicarbonate buffer which is present in the blood, the person is able to balance the pH at around 7.4 and is staying alive, or else the person might even die. Talking about our environment, acid rain is of prime importance. When the pH of the rain falls below 5.6, it is called as acid rain. The rainwater combines with gases like sulfur dioxide and oxides of nitrogen to form sulfuric acid and nitric acid, and when it falls and reaches the rivers, it is also going to drop the pH of the river water. And this is in turn going to affect the aquatic life and the environment. So the presence of natural buffer in rivers, it helps to maintain the ecosystem. To conclude, we find that acids and bases are part of our everyday life. Strong acids and strong bases are completely dissociated in water, whereas weak acids and weak bases are partially dissociated in water. pH is the potential of a substance to attract hydrogen ions. And a buffer is a substance which can resist the change in pH on addition of small amount of acid or base. pH and buffer are of prime importance in living system and in our environment. Thank you.